All right, so these notes are the notes for section 4.3 in your textbook. And so I decided to record this ahead of time just to ensure that you have the notes. And so I'm going to go directly into example 1 of 8. So in example 1, we begin with the product rule. So the product rule by default is this basically states the following. It says let B, M, and N be positive numbers. So these are positive real numbers. With B, the base, not equal to 1. And so the rule of thumb is that if I have log base B of M times N, that's what that represents, this is equivalent to log base B of M plus log base B of N. And so this becomes the sum of two logarithms. So an example of this would be if I have log 7x, this is equivalent to log 7 plus log x in this case. Same thing would apply if it's natural log, so I'll just show you natural log together. This is equivalent to natural log 7 plus natural log x. All right, and so in example 1, they ask you, this is what your question will look like. It would say using the product rule, it says use the product rule to expand. And then in A, they give you log base 4 of 7 times 5, which they may present to you as, for example, log base 4 of 35, and then they would tell you to use 7 and 5, which you would do that. In example B, they give you, notice that there is no base, and then 10x. So remember what I said to you, when there's no base present, just remember that there is a 10 sitting here. So it's log base 10 basically. And so our solution for the first one would simply be to express this as log base 4 7 plus log base 4 of 5. You don't have to simplify or anything, they just want you to expand. Now this one is a little different. I want you to go back to that expression that I said to you, that when they don't write a base, we assume it's base 10. And so in the first step, you're going to say log of 10, all right, plus log of x. Now you just have to remember that in this case, there's a little 10 here, and so 10 to the 1 would give me a 10. So this actually becomes 1 plus log base 10x. We're just assuming it's base 10. Okay, if you wish to try another 2 examples, here's C, I'll call it C, and I want you to do log of base 6 of 7 times 11. All right, we try that one, and then we can also try for D, another trial. We could do log of 100x. I'll give you a minute. So as we solve this first question, you should basically have log base 6, 7 plus log base 6, 11. That's all you need to do for that one. Because remember, they're just asking you to expand. Here I have log base 10, if you recall, that's sitting there, of 100 plus log of base 10x. And so we know that 10 to the second power will give us 100. So this is actually a 2. This becomes 2 plus log x. And remember, we're assuming that little base 10 is there. So we don't necessarily have to write it. Again, I just wrote it to remind you that there's a little 10 there. All right. Let's now look at example 2. In example 2, we're talking about the quotient rule. All right, so in the quotient rule, we're going to remember the rule that says, again, let B, M, and N be positive real numbers, and obviously B cannot equal 1, so B is not equal to 1. Then we say that log base B of M over N is equivalent to log base BM minus log base BN. So basically the difference of the logarithms. All right, and so we're going to start with the first example. They say in this case we want to expand the following. And so they start you off with example A, where they say in this case log base 7 of 19 over x. So that's our first example. And so when you expand this, you simply do log base 7 of 19 minus log base 7x. And that's all you need to do for this particular question. Now, the second example they give you does have a little bit of an extra step because it's a natural log and they have a couple of special letters in there, the values. So you have natural log e to the third over 7. And so if we expand this, you're going to end up with, in this case, natural log e to the third minus natural log of 7. What happens is natural log and e will cancel. And the result of this is basically going to be that you're left with 3 minus natural log 7. Okay, and that's a condition of natural log and natural base e. So let's do these two just for good measure and make sure that we're in a good place. So example C, I have log 8 of 23 over x. And for D, I have natural log e to the 5th over 11. Okay, and so in this case, I'll give you a couple of minutes. So looking at the first one, you probably wrote log 8 of 23. That was 23, not 33. minus log base 8 of x. Okay, in this one, if you started writing it out, you probably had natural log e to the 5th minus natural log 11. Okay, remember, natural log and e cancel. So you should have 5 minus natural log 11 because there's not much you can do there. All right. Example 3. In example 3, we're dealing with the power rule. And in the power rule, we simply need to remember that if I have, for example, log base b of m to the b, then the equivalent value here, actually they use a p, not a b, so let me change that. It's actually a p, that this will change to the power of p times the log of b to the m. All right, so let's look at an example. So if I have, they want us again to expand. So they're giving us expand log base 5 of 7 to the 4th. They're asking us in example 2 to expand natural log of the square root of x. And the third example they give us is log of the product for x to the 5th. So I'm going to start with the first question, or first example. So this one is simply for log base 5, 7. So if you notice, the only difference here is this 4 is now that. That's it. Here in this one, I'm going to change the color just for visual purposes. This becomes natural log of x to the 1/2 power, right? Because that's what the square root indicates. This then reduces to, or expands, not reduces, to 1/2 natural log x. And we can't do anything else. We're done. Okay, in the last example here, the first thing you're going to get is 5 log of, again, for x. They did not ask us to go further, but if we did go further, remember that's a product. All right, and so I'm going to leave that one the way they want us to stop. So let's do some more for practice. So I'll give you examples 4, 5, and 6, and let's see how you do. And so you have log base 6 of 3 to the 9th. Again, the direction is to expand this. Okay, and so in this case, this expands, again, it's just simply moving the exponent forward, and then this leaves us log 6, base 6. Okay, here we have natural log of the 3rd root of x. So the first thing we do is say natural log of x to the 1/3, which we now refer to as 1/3 natural log x. All right, and then the last one, since they just want us to expand, they give us log of x plus 4 to the 2nd power. We're not going to do anything fancy, we're just going to focus on the power rule, so it's 2 log of x plus 4, and that's it. That's all you got to do. All right, so those are the general properties. So just to summarize them here. So we have the power, the product, and the quotient. So we started with product. And so product rule simply says if I have a log base b of m n, that the result is basically log base bm plus log base bn. The quotient rule, these are rules. So the quotient rule for us is simply going to state that if I am given log base b of m over n, that this simply becomes log base bm minus log base bn. All right, and then the last one that we just did is the product rule. All right, and in the product rule we have again it would be log base b of m to some power, and so when we expand it, it would be p times log base b m. Okay, now in example 4, which is the next example that we need to focus on. In example 4, we're expanding logarithmic expressions. So it's more of the same. The only problem here is that they're getting a little bit more complex. Let's just say that. Okay? So here's example 4. We are going to expand logarithmic expressions. So I'm just going to put log because it's a long word. Log expressions. And so they start us with example A. I'm just going to do one at a time because they take a little bit of space. So they give us log base b and then parentheses x squared and then square root y, and the rule is, or the request is to expand it, basically, expand. All right, and so here's what I notice immediately. This is just log base b x squared plus log base b of y to the 1/2. I'm not done. Next thing I need to do is bring all of these forward. And so my last expression should be 2 log base bx plus 1/2 log base by. All right. So again, you notice in this one we had product rule because this is a product, and that's what what we addressed. Once we separated the expression, we now have the power rule, which, if you notice, that's the next thing I do. All right, in part B, or example B, they give us log base b of the cube root of x over 36 y to the 4th power. So obviously that you could tell this is quotient rule right off the bat. So the first thing you should try to do is express it just as is, and then also consider that this value, for example, on top is x to the 1/3. This is minus the log base b, because it's not, oh, it is base 6. I'm sorry, base 6. This is not a b, it's a 6. I wondered as I was writing it, and then I finally looked, and I'm like, oh, okay. So again, log base 6 of 36 y to the 4th. I also want you to notice that technically, so if I'm here at this point, I've expanded it with each of the powers. Remember, this is a product. This is 36 times y to the 4th, so you need to take an extra step. So this is log base 6 x to the 1/3 minus I like doing this. Log base 6, 36 times log base 6, actually plus, I'm sorry, I had a moment, plus log base 6 of y to the 4th. So now I'm looking at these two expressions, and I'm thinking let's apply the power rule now. So this is actually 1/3 log base 6 x minus, now I want you to stop and think, log base 6, 36. 6 to what power is 36? Obviously 2. I like keeping it in the bracket. And so the next step, bring that forward. So this is 2 plus 4 log base 6y. Excuse me. At this point, you're done. You don't need to do anything else. You could even remove this because it's just a visual aid. Just remember that negative goes into both of those, so your final answer is minus of 4 log base 6y. Because remember, this negative goes in here. This negative is going to affect this value, and it's going to affect this value because there are brackets here. So always remember, keep them separate so you don't have that issue. Let's practice one more of each of these. So I'm going to call this A in red. This will be checkpoint 4. So this is called log base b x to the 4th cube root of y. All right, and so I'll give you a minute to do that one. So this should give you, once done, 4 log base 6 x. Remember, this is a product, so it's plus 1/3 log base 6 y. I think I called this b again, and again, I apologize for that. It wouldn't really matter if it's b or 6, as long as you're consistent for this. This one, it didn't matter. All right. Any questions on that one I need to know? And if not, I'll move on. So for this next one, I have log base 5 square root of x over 25 y to the 3rd. Again, difference is a quotient rule. So this is going to become log base 5 x to the 1/2 minus log base 25, and again, start putting parentheses because this is a product, plus log y to the 3rd all right, and so 1/2 log base 5x, and this is going to affect this value and this value. Remember that this is log base 5. I missed the 5s. So 5 to what power is 25? Obviously this is going to leave us a minus 2. That's going to be a negative, so that'll become 3 log base 5y. All right, and that's your final answer for that. All right, so these are the properties for condensing logarithms. Let me talk to you about these again. So properties of condensing logarithms. The prior ones were expanding logarithms. basically it starts with log base bm plus log base bn is equal to log base b m times n. So this is your product rule. Your quotient rule would look like this. It would say log base bm minus log base bn, and this condenses to log base b of m over n. So if you notice, it's always the first value that goes on top. And the last one's the power rule, where if I have the power times the logarithm of a base m, that condenses to logarithm of base bm times p. So we're just going the opposite direction. So I'm going to do example 5. In example 5, we are condensing logarithmic expressions. All right, so I'm condensing logarithmic expressions. All right, so we start with A. If it says write in a single logarithm, that's what they'll tell you. Write in a single logarithm. Okay, and so they start you with example A, where they say log base 4 of 2 plus log base 4, 32. And so this is where we begin. And so if I'm condensing this is addition. This tells me it's product. So what I should have is log base 4 of 2 times 32, which is basically log. Sometimes you can finish these and actually get a value. So in this case, this becomes 64. And we know that 4 to the power of 3 is 64. So this final answer should be 3. Remember when we were working with these earlier and I said to you, just put an equals x here. So this becomes, I'm going to go this way. This becomes 4 to the x is 64. And if you didn't know this, you know now that 4 to the third power is 64. So knowing your powers helps. But if you didn't, you would say x equals the log of 64 over the log of 4, and that will give you 3. Okay? If you look at example B, then you have the log of 4x minus 3 minus log x. Okay, we already see that this is subtraction, but this is still one number. So this is like equivalent. So this would be like log of 4x minus 3 over x, basically. That's pretty much all you have to do. All right, so if you want to try 2 of these, I'll bring this down, scooch it over just a snag here. All right, take a look at this. Here's, I'm going to call it A1, where I have, in this case, log 25 plus log 4. And then for BI, I'm going to give you log of 7x plus 6 minus log x. All right, so you notice in this one, you're going to get log of 25 times 4, which is basically log of 100, right? And remember what I said, there is a little sneaky little 10 hiding in here. So 10 to what power is 100? Well, 2. 10 to the 2 is 100. So you remember that backward C I told you to remember. Here we have the quotient rule. So we have log 7x plus 6, all of it over x. And that's all you have to do for that. All right, we have examples 6, 7, and 8, and we are great. So let me do example 6. Now, example 6, we're still condensing. We are condensing a logarithmic expression. And so if I'm doing that, it says basically write as a single logarithmic expression. And in this case, they're going to give you 3 examples to try. So I'm going to start with A. So they give you 1/2 log x plus 4 log of x minus 1. We'll start with that one. And so the first thing you're going to want to take care of are the powers. So you're going to go that way on the powers. That's number 1. So what we really have here is log x to the 1/2 plus log x minus 1 to the 4th. Next thing we do, since it's plus, these two become products, or multiplication basically. You should end up with the log, and it doesn't matter if you write square root of x or x to the 1/2, okay? So I'm going to leave it so it's visible. X to the 1/2 times x minus 1 to the 4th. And all of this is your answer. All right, so if you want to try one of these, I'll give you an A1. A1 tells us we have 2 natural log x plus 1/3 natural log x plus 5. Okay, and so again, I would take care of the powers first. I would take care of these powers first, and so I have natural log x to the 2nd power plus natural log of x plus 5 to the 1/3. Now these become products, so you really have natural log of x squared times x plus 5 to the 1/3, and that's your value. So I think you'll be all right with these. Let me give you examples B and C. You can try them right now. So for example, B, they give you 3 natural log of x plus 7 minus natural log x. So this is quotient rule, right? So first, are there any powers? So yes, there is. So in the first one, there is a power of 3. So I'm going to raise this to the 3rd minus natural log x. This is a negative, so it's a quotient. So this is natural log of parentheses x plus 7, to the 3rd over x. And that is your final answer. That's not terrible at all, I hope. So let me give you B1 as an example, or BI, whatever you're calling it. Have a nice day, it doesn't matter. So this is 2 log of x minus 3 minus log x. So once again, what's the first thing we do? We take care of the power. So we have log of x minus 3 to the second power minus log x. This is the negative, so it's a quotient. So this is really the log of x minus 3 squared over x, and that's it. All right, let me do example C with you. This will be fun. Example C, I have 4 log, it's just longer, it's the same stuff. 4 log x minus 2 log, of course I use base b. Actually, this is a base b also, I forgot to write it. So they're all base b minus, and this is log base b6 minus 1/2 log base b of y. I don't know why I just put that parentheses there. This is habit. All right. So when you look at a question like this, don't panic. Just follow the rules. The first thing you do is any exponent, we're going to bring it to the front, bring the exponent to the front, bring the exponent to the front. So that's step 1. So that gives us log base b of x to the 4th power minus log base b of 6 squared minus the log of base b y to the 1/2. All right, and now we begin the process. This is where people get confused because you notice there's 2 negatives. All right, pay attention to the step. Look at what's going to happen. This is log base b x to the 4th. We are subtracting from it log, all of this basically, log base b 6 to the 2nd, which is 36 in essence, minus log base b y to the 1/2. So here's what we have to consider. Because this is a negative, if I put a parentheses around here, what happens is this becomes positive, as does this, because I'm extracting the negative. Okay, so what you really have here, once you set these parentheses, keyword, I set the parentheses, I have to consider that if originally this is negative log of this and this is negative log of this, that if I'm extracting a negative to make these 2 positives, this is what I get. I get log, this becomes a plus, this becomes a plus. Because remember, it's kind of like these negatives disappear for them. Okay? So this is still minus all of this. This is now, again, this becomes log base b 36 plus log base b y to the 1/2, right? And again, remember both of these originally had little negatives, so I'm just going to put a little dot to remind you, both of these were negative at one point. You took out the negative, then these became plus themselves. So this is really now log base bx to the 4th minus log base b 36 times y to the 1/2. Because remember, this is a plus. You're adding the 2, so you're really multiplying the 2. When I say the 2, I mean this and this. I already have log base b here. So if that is the case, then this now becomes log base b of x to the 4th over 36 y to the 1/2. So if you need to stop and think about this or talk to me about it, let me know. That was a fun one, huh? That was fun. Let me give you a try question. We're almost done, by the way. So I want you to try this. This is C1. And C1 says I have 1/4 log base bx minus 2 log base b of 5 minus 10 log base b of y. Okay, so I'll give you a minute and change to finish that. Okay, and in this case, your final answer for here should be log base b of the 4th root of x divided by 25 y to the 10th. All right, so that should be the answer. If you need to discuss this with me, just tell me. I'll stop the video and we'll discuss it. All right, so that was example 6. Let me do example 7. In example 7, we're changing the base to common logarithms. All right, so just to give you an example, if I have, it says use the common logarithm, let's put CL, common logarithm, to evaluate. And this simply involves calculators, people. These last two examples are ridiculous. So we have log base 5 of 140. Remember what I said to you to always think of, you know, in the sense of equals x. Think of this as the b, this is your base, and this is your m, right? And in the example they give you, they say log base b of m is equal to log of m over the log of b. Now in my example, I always tell you, think of this as equals x. So it's kind of like 5 to the x is equal to 140, and then you re-express this as x equals the log of 140 over the log of 5. Use your calculator, you get your answer. I believe the answer to this one is 3.07, so please try with your calculators. Example 8 is no different. The only difference in example 8 is that we're talking about natural logarithms. So we're changing the base of natural logarithms. Same difference. So they're asking us to evaluate basically log base 5 140. And so you can simply express this as well as natural log of 140 over natural log of 5, despite the fact that this is log. It wouldn't make a difference in your answer. And your answer should still be 3.07. So both of those are literally identical. And that's it. That's the notes for 4.3. So one more step in the right direction. We're getting there. We're almost done.